In this lesson, we are going to be solving square root functions. The steps for solving square root functions are pretty much the same as they've been for solving anything, with the exception of, how you undo something. So step number one is going to be to isolate the radical. And there's going to be some problems, as you see over here. I'm talking about there's 3 different problem types. So there might be more than one radical. So the idea is that you isolate the one that has the x, and the x is going to be underneath the radical. To undo that radical, we're going to square both sides, and then the x should be out from underneath the radical, and you should be able to get x by itself. However, there are 3 types of problems. So, and depending on what type of problem it is, this process may look a little different, but it should be pretty much the same thing each time. We'll see as we work our way through them. Okay, so the first type of problem where you have to solve a square root is going to be where there's only one radical. It's going to be on one side of the equal sign. There's only going to be one radical, and the variable, the x, is going to be underneath the radical. Okay, so that's this kind of problem. So this is type 1, example 1. So we're going to isolate the radical. So we need to get this x minus 2 needs to, we need to undo anything that's on the same side of the equal sign with that radical. So that means we need to isolate the radical. We need to move the 5. So we're going to do the opposite by subtracting 5 from both sides. And we have our radical. We have a 0 over there now, so I'm not going to put anything, and then 17 minus 5 is 12. So my radical has been isolated. So now I'm ready to square both sides. So you put the little square up here, you put the little square up there. The square and the square root cancel each other out, so the x minus 2 is now no longer under a radical. It's just x minus 2. And that's equal to 144, because that's what 12 squared is. Now, says step number 3 is solve for x. So we just have to get the x by itself. What do we do to get the x by itself? We undo whatever is happening to the x. It says x minus 2. We're going to undo that minus 2 by adding 2 to both sides. And that leaves us x equals 146. So this next example has, you may think at first it doesn't have a radical, but remember, if it's being raised to the 1/2 power, like this right here is, then whatever is inside that parentheses is really under a radical. So if we were to rewrite this, let me see if I can rewrite it real quickly. Up here, it could be rewritten as negative 36 equals negative 9 radical c minus 12. So these two are the exact same equation. You should be okay with it being a radical or to the power of 1/2. The steps are going to be exactly the same. We need to isolate the radical, so we need to isolate whatever is being raised to the 1/2. So this needs to be isolated. So what does that mean we need to do? We need to get rid of the negative 9. That's not going to be by adding 9, because that's a negative 9, but it's not being subtracted from the radical. It's being multiplied by the radical. There's a multiplication symbol right there. So how are we going to get rid of the negative 9? We're going to divide by negative 9, because the operation right there is multiplication. So we're going to divide both sides by negative 9. That's going to leave the c minus 12 raised to the 1/2. It's going to leave that isolated, and then negative 36 divided by negative 9 is negative 4. So we now have the radical isolated, and if you want to rewrite it as a square root and solve it that way, that's perfectly fine. I'm just continuing to work this because I want you to be okay with it either way. So what did we need to do right here? We need to square both sides, and squaring both sides is still going to be what we're going to do. We're going to raise this thing right here to the second power, just like we're going to raise this other side, -4, to the second power. And what happens when we have a power raised to a power? We've got 1/2 raised to the second power. What do the laws of exponents say when we have a power raised to a power? What do? We multiply. And so when you multiply 1/2 times 2, they cancel each other out, leaving you with an exponent of 1, which is exactly what we want. So the c minus 12 now has an exponent of 1, so there's no reason to put it. And -4 squared is 16. So I'm going to finish isolating the variable. C is the variable this time instead of an x, and you should be okay with that. I need to get the c by itself. What's happening to the c? We're subtracting 12 from it. So how do we undo subtracting 12? We're going to add 12 to both sides. So I'm going to add 12, that adds to 0, and c is equal to, I believe that's 28. Okay, this is type 2, example 1. Type 2, example 1, type 2 meaning that we've got a square root on both sides. If possible, it may not always be possible, but if it's possible, if you have a square root on both sides, then you're going to need to isolate those square roots. On this particular problem, both radicals are already isolated. There's going to be well, I'll just go ahead and make this one. Let me just change this problem. Let's stick a 2 in front of that. So in this case, it's not exactly isolated, but isolating that would require me to divide by 2, and then I'm going to have a divide by 2 over here on this side, so it's not helpful. There is no way to completely isolate it. But if it's just a multiplier, a coefficient like this one right here, it's not going to make the problem that much harder. So it'll work out fine. So when there's a square root on both sides and there's nothing being added or subtracted to either end, that's when it's added, subtracted, that's when it becomes a problem. Then it's pretty simple. They're already isolated, so what are we going to do? We're just going to square both sides. So you do have to be careful on this one. People are going to forget. This is going to be where you're going to make the mistake. We have to square both sides. And when you square this side, yes, that's going to cancel out, but you have to remember to square the 2. So once this radical is gone, you have 4 times u minus 8. And then we will end up this next step distributing that. And on this side, the square root and the square cancel each other out, and we're left with 43 minus 2u. I failed to mention earlier that you should check, because it is possible to get extraneous solutions. So you might want to check and make sure that when you plug in this 146 back up here, that it doesn't cause us to get a negative underneath there. Because we know if you have a negative underneath there, you now are dealing with imaginary numbers, and these are wanting us to deal with real solutions. So if you plug in 28 up here, are you going to get a negative number? No, we didn't get a negative number, so we're good. You do have to check for extraneous solutions. Okay, so back to this one. I've distributed, let's see if I can move this down a little bit. Distribute the 4, that becomes 4u minus 8, and that's equal to 43 minus 2u. I need my u's all on one side, so I'm going to add 2u to both sides, and 6u minus 8 equals 43. Add 8 to both sides, and 6u is equal to, what is that, 51. And then, of course, my last step is to divide both sides by 6. I don't think 6 will go into 51 evenly, so I'm going to reduce that fraction to its lowest form. 51 divided by 6 reduces down to 17 over 2. and I just let my calculator do that for me. 51 over 6, it looks like what's the 3's canceling out? So 51 is 17 times 3, and 6 is 2 times 3. The 3's cancel out, leaving me 17 over 2.